So we're talking about imaginary and complex numbers. So, I mean, just think about this. How would you solve x squared plus 4 equals 0? It was unfortunate that I did that. Okay. Back. There we go. So how would you solve this? I mean, if you were to subtract the 4 from both sides, you end up with x squared equals negative 4. And now if you were to take the square root of x squared, this is what we normally would do, we have the square root plus or minus of negative 4. So x would be plus or minus the square root of negative 4. And, I mean, yes, we could look at that and say, well, I see that's the square root of plus or minus 4 times negative 1. And I know the square root of 4 is 2. What's the square root of negative 1? Well, this is where we come up with the concept of the imaginary number. Imaginary number. That we identify negative 1, square root of negative 1 to be I. So we would call this plus or minus 2i. I for imaginary. So imaginary and complex numbers. Here's our written definition. A complex number is a number of the form a plus bi, where a is the real part of the complex number, and bi is the imaginary part of the complex number. So if b is equal to 0, then the bi part is just 0, and it's just a. You get a real number. If the a part is 0, then you just have, and b is not 0, you end up with just the bi, which is an imaginary number. So an imaginary number is an even root of a negative number. So you can take like the cube root of a negative and it's fine, but like square root, fourth root, and all that, you have to work through imaginary numbers for that. So just want to get this point across. So what we can boil it down to is that the square root of negative 1 is the I. And we did talk, and I'm kind of getting off script here, now that I really have a script, that we talked about, our world of whole numbers, and then actually I had natural numbers first. Come on, erase. We have, I think we're taxing the computer with too many things. We have natural numbers, then the world of whole numbers, then the world of integers. Notice these are inside that world, or like a Venn diagram. Then we have the world of, how do I want to say the next thing? So we have integers, then we have rational numbers. That's this, yeah, I guess these fall within the world too, yes. Rational numbers. Then we have irrational numbers. There's another world like that. And this whole world, and I shouldn't have any gaps, but these are the real numbers. But all this is in this other big world. I don't want to make it look like it's an overlap. So we have imaginary numbers, and then together these make the world of, let me do that. Together, imaginary and reals make the world of complex numbers. Or I think we just call that C. So just trying to show you that the relationship in these types of numbers in our sets. So if we look at the square root of negative 24, what would that be in standard form? Well, let's look at the square root of negative 24 in terms of its factors. Is there a perfect square in there? Yes, there is. 4 times 6, and then times negative 1. So we could treat this as the square root of 4 times the square root of negative 1 times the square root of 6. Square root of 4 is 2. Square root of negative 1 is I. So 2i times the square root of 6 is how we'd represent that. Now, on the complex plane, when we have an a and a b, even if you just had one of them, you plot it on an axis. But if we were to plot something like negative 2 plus 3i, the x-axis is the reals, r, and the y-axis is the imaginary. So negative 2 plus 3i means we want negative 2 for the reals, 3 for the imaginary, and that's why that's up there. So in a general note, our complex plane has the reals as the horizontal and the imaginary as the vertical. So how to represent a complex number on the complex plane. Determine the real part and the imaginary part of the complex number. Move along the horizontal axis to show the real part of the number. move parallel to the vertical axis to show the imaginary part, and then plot the number. So we're going to plot -4 minus I on the complex plane. So the real part is -4. The imaginary part's -1 because it's -1I. So it's right here. -4 minus I. -1 times I. If that helps to see it that way. Or maybe as a plus -1. I don't know. Whatever's more meaningful for you. And I think that's it for this one. We're going to go on to adding and subtracting complex numbers next.